All right, so in this question, June 2017, question 1. That's the next question we are working on. All right, so now we've got this. To keep track of his profits, the owner of a carnival booth decided to model his ticket sales on a graph. He found that his profits only declined when he sold 10 and 40 tickets. So they're saying that his profits are only declining when he's at 10, between 10 and 40 tickets. So let's see, where do we see a decline between 10 and 40. So this is the number of tickets sold, right? Here it's constant. Okay, so it cannot be that. What about choice number 2, between 10 and 40? What is happening over here? Is this a decline or an incline? I think it's increasing, right? It's a combination of both. What about this one? 10, choice number 4. It's going up, then it starts coming down. What about this one? Is it decreasing? This is declining. So it's answer choice 3. So here we've got this question to figure out which graph represents square root x minus 2. That is really simple way. Just plug it into your calculator or Desmos and see which distinctive shape follows it. Remember, any x squared graph, a quadratic x squared shapes will be like this, 1 and 3. A straight line will be like this, y is equal to mx plus b. These will be y is equal to ax squared plus bx plus c. So you'll get that 1 and 3 if you have an x square shape. Mx plus b is option number 2. Look at question 4. I drew the graph on Desmos and this is the shape I get. These are interlinked. Right, so our answer choice is 4. There's a negative half. So we have this graph and we've got to determine which equation satisfies this graph. So remember, it's a maximum graph. Okay, so the coefficient of A should be less than 0 or negative. Okay, some clues. Now when we expand any of these, we know that we'll get an x squared, right? And then there's a parentheses outside. So if I multiply half by x squared, I'll get an half x squared. But that's a positive value. I want a maximum, so I need a negative value for the coefficient of x squared. So this value should be a negative value. Let's check the second one. There's a negative half. And then if I expand, I get an x squared. So this one could possibly be one of the options. So this works. Okay. And then option 3 is the same as 1, so that doesn't work. Option 4 could work because it's got that same negative thing. So let's test the conditions. So I'm going to plot these graphs and see what I get. So I drew the graphs on Desmos. And the green option is choice 4. This one right here, choice 4. Right? And the blue option is choice 2. Now what are we looking at? Look at our original graph. It's all in the positive part, right? Which graph would that be? This one right here? This is all in the negative. So therefore our answer choice is 4. So I got the table for this graph. We've got to draw the graph of negative x squared minus 6x, and I've got the table right here. You can get this from your calculator. I use Desmos, but let's look at these set of values and mark these as I keep reiterating. Let's mark some negative values. -7, right? And then we've got -1, -2, -3, -4, -5, -6, -7, and 1, 2, 3, 4. So this is the easiest part of the points. You can get these points as easy as you would like it to be. Okay. Okay, so we've got these things now, right? Let's plot. So now -7 is -7, which will be down here, right? -7 on the x and -7 on the y. Then -6 and 0, which will be right here. Then -5 and 5, which will be up here. And then -4 and 8, -4 and 8, -3 and 9, and then -2 and 8, back to coming down, -1 and 5. See how symmetry occurs in these questions, 0 and 0, 1 and -7. And then you just plot this, right? So you get this as your shape of your graph. So that's the first part. Then they're saying state the coordinates of the vertex. The vertex is where the graph turns. So wherever the graph turns, minimum or maximum, wherever, this is a maximum point, right? Remember, even from here, this part is negative. So the coefficient of x squared is negative. You'll always get a maximum point. What's the coordinates of that vertex? -3 and 9. Put that as your answer. That's the coordinates. Alright, so now we've got this question, June 2017, question 5. So the graph is showing Craig's trip to visit his friend in another state. In the course of his travels, he encountered both highway and city driving. So that's our situation, right? So it's a 230-mile journey, as you can see, and he's covering it in 7 hours from here. 230, right? There are 3 questions here. Let's try to find what all is happening. Okay, so question 1, they say based on the graph, during which interval did Craig most likely drive in the city? Now there are 3 sections where he's driving, right? So where do you think that would be? Right here, right here, and then right here, right? Where do you think he's driving in the city? So obviously city driving is slower than highway driving, right? You probably experienced this. So in the city, you drive slower than at the highway. So let's find the slope for all of them. So to find the slope, you just make a right angle triangle every time. So this is 2 hours right here. So this length is 2. And from here to here, it's 110. So what's 110 divided by 2? 55 miles per hour. Do you think that's at the highway or in the city? So that's the highway. Right? Let's check the second part. Now this is 1 hour. And from 110, it's moving up to 200. So that's 90. So what's 90 divided by 1? That's again the highway, right? You wouldn't drive at 90 in a small town, right? Remember the slope formula is delta y over delta x. Okay? Be signified by the symbol m. Okay, let's try the second section. So from here to here, this is 2 hours, right? And how much is it covering? 30 miles in 2 hours. So what's our speed over here? Here it's 90 miles per hour. And here 30 divided by 2, as we use this formula, right? We'll get 15 miles per hour. So where do you think he's driving in the city? Right here. Right? So, which interval is it between D and E? Right? And they say explain your reasoning. He is traveling at 15 miles per hour. Or you could say that he covered 30 miles in 2 hours. That's relatively very slow. Right? Okay, explain what happened between intervals B and C. So that's between these 2 points. That is a 2 hour space. What do you think must have happened? Is he stuck in traffic for 2 hours? Maybe. Could that be possible? He could be stuck. Could he have taken a break? Could have taken a break. A 2 hour break. Right? That is possible, right? So you can say maybe he's stuck in traffic. And these are, again, we are just looking at logical responses for this question. Or is taking a break for 2 hours. So anything in that order or direction will get you a correct point. Okay. Then they're saying find his average speed. What is average speed? Distance divided by time. What's our distance? It's 230 miles. What's our time taken? 7 hours. So our final answer will be 32.86 miles per hour or 32.9 miles per hour. That's our average speed. So in this question, the graph models the height of a remote control helicopter over 20 seconds during flight. Over which interval does the helicopter have the slowest average rate of change? So the slowest will be the steepest, right? but with a negative aspect. Remember, negative lines are like this. Negative slope. Positive slope is like this. Okay? Positive and negative slope. Now, where all do we have negative slopes? So, from 0 to 0 to 5, there's a negative slope. From 5 to 10, it becomes positive because it's going up. Then from 10 to 15, again, it's negative. And then from 15 to 20, it's again positive. So we can skip two of the answer choices, 5 to 10 and 15 to 20. Now, which one is steeper? So let's just put in two lines here and make it easy for us to work with. So if I extend this line, right, throughout the page, this is what I get. And then if I join these two, this is what I get, right? So which line is steeper, the first line I drew or the second line? Which one has a higher incline? The first line. So therefore our answer choice will be 0 to 5 seconds. Answer is 1. So here we have August 2017 question 2. Winona sketched the polynomial px as shown on the axis. So she sketched this graph. Now if we mark some points, this is 0, 1, 2, 3, 4, negative 1, negative 2, right? So we know when x is 2 or negative 1, y is 0. So if I were to show this at negative 1 and 2, what's the value of y at 0? So one way to work with this is that if I put in these values and I have a third value, if I use x as 0, what am I getting here? 1, 2, 3, 4. So when x is 0, I get y as 4. So let's look for this option, okay? So let's use this part, this piece of information. X is equal to 0, y is 4. Let's plug it in maybe answer choice 3, right? So if I put P0, what do I get? 0 plus 1 and 0 minus 2. Now what's 0 plus 1? It's 1. What's 0 minus 2? Negative 2. This is negative 2. But we need 4. So this one doesn't work. So I'll strike this. Strike this. Now similarly, answer choice 4. Px is equal to x minus 1, x plus 2. Let's plug in 0. P0 is equal to 0 minus 1, 0 plus 2. Let's see what this solves as. Negative 1 times 2, negative 2. Again, same situation, right? Doesn't work. Now, we need a 4. That's what we are trying to get. This is what we are looking for. When x is 0, y is 4. So let's try answer choices 1 and 2. Maybe it works, right? Let's try. So, let's try 1. Now if I put 0 in here, what do I get? 0 plus 1 and 0 minus 2 whole squared. I'll get a 1 and negative 2 squared is 4. Use the parentheses on your calculator and you'll get positive 4. So I get a positive 4, which is what I want, right? And let's try just to make sure there's no conflict in the values or the answer choices. Let's try this one. So I get negative 1 and I get 2 squared. 2 squared is 4. Negative 1 times 4 is negative 4. So this doesn't work. So what are we left with? Answer choice 1. So our answer is 1. Another way to do it is plot all these graphs on your calculator or on Desmos. And you'll get this distinctive shape. Whichever graph is similar to the one that is given is the answer choice. Alright, so we've got this. A manager wanted to analyze the online shoe sales for his business. He collected data for the number of pairs of shoes sold each hour over a 14-hour time period. So that's our situation. He created a graph to show what's happening. The manager believes the set of integers would be the most appropriate domain for this model. Explain why he is incorrect. So why do we think he's incorrect? Now he's using integers, right? So potential reason would be because of time can be decimals or fractions, right? 2.5 hours, 2.25 hours, those are not being considered. So he's just using integer values, right? You should also use more divisions to get a more accurate response. Okay, the next question we've got is state the entire interval for which the number of pairs of shoes sold is increasing. So this is the number of pairs sold. So where is this increasing and where is it decreasing? So it's increasing over here, it's still increasing, it's still increasing. And after that, so it's increasing in this direction. After 6 hours, it starts decreasing. So what would our response be from 0 to 6? In this time interval, it is increasing. So 0 to 6 hours. Okay. Now we have the last part. Determine the average rate of change between the 6th and 14th hours and explain what it means in the context of the problem. So what we are doing is what is happening between 6 and 14, right? And we need the average rate of change. So basically what we are asking for is the slope, right? Change in y over change in x. So let's take this point. What is it? 6 and 120. And let's take this point, 14 and 0. Right? Now from 120 it's coming to 0 on the y-axis. So that's a decrease of 120. And on the x-axis it's changing from 6 to 14, so that's an increase. So it would be 14 minus 6. So we are getting a negative response, negative 120 over 8. We can divide by 4, so we get 30 and 2, and then 30 divided by 2 is 15. So negative 15 shoes per hour. So basically the sales are going down every hour after 6 hours. So this would be a potential, like if you see a company will be concerned with this. Like should they open for 14 hours a day? Would that be a good option for them, or is this just seasonal? This is just for maybe a few days. Some days can be the total opposite of this and so on. So critical decisions can be made based on this graph or this piece of information. Alright, so we have this next question. So they're saying that a function is defined as 0, 1, 2, 3, 5, 8, 7, 2. Isaac is asked to create one more ordered pair for the function. Which ordered pair can he add to the set to keep it a function? Now remember that a function has to have these conditions. 1x goes to 1y. This is what we are looking for, right? Now if we draw the mapping for it, we've got x and y. So this is 0, goes on to 1, 2 goes on to 3, 5 goes on to 8, and 7 goes on to 2. So we've got these set of values. Now let's look at our answer choices. What are our answer choices? 0, 2, 5, 3, sorry, number 3 is 7, 0, right? And number 4 is 1, 3. So now if we look at all the answer choices, look at the x values. We need 1x is 1y. The x's should not repeat. Let's look at the answer choices. In answer choice 1, we have 0 right here. This is in our initial mapping. Then 5 is also in our initial mapping. Then 7 is also in our initial mapping. The only one which is not in the initial mapping is this one. Look at it. There's no 1. 1 is right here. And it goes on to 3. So 2x's can go to 1y, or 1x can go to 1y. That's how you can figure out if something's a function or not. Alright, so we've got this question. Graph fx is equal to square root x plus 2 over the domain -2 and 7. So we can easily work on this question. Either use your calculator and put in the equation, or use Desmos and get your equation and table. So 2 things that I always require from you: table, graph. This will get you your full points. Alright? So let's draw this on Desmos or on and there we are. That's our solution. So next we have this question. Caleb claims that the ordered pairs shown in the table below are a non-linear function. What does non-linear mean? Not a straight line. So linear is straight line, non-linear is not a straight line. Now let's look at our values. X is 0, 1, 2, 3, and fx is 2, 4, 8, and 16. So I drew the graph for this, and this is what I get. It's not a straight line, so it's a non-linear function, so he is correct, right? So what should we write? We should say that Caleb is correct, since the set of points do not or represent a nonlinear graph. Represent a nonlinear function as shown. And one advantage of drawing this graph is that it's self-explanatory, right? Therefore, you're encouraged to always draw diagrams, tables, graphs. Use those to your advantage. So we have this piecewise function over here, or this piecewise graph. Piecewise function or piecewise graph is that it's got 2 tiers or 2 parts. So this is one part, and this is your second part. So you'll draw it separately, okay? So let me mark some points. So we've got a few points, right? Now what you're supposed to do is just plug this in your calculator or Desmos, however you're working. And then once you plug it in, you get a table. Plot that table, use that table to plot your graph, and you'll be able to get a shape, right? And one of them is below 2 and the other one's including or above 2. When we have an equal sign, like in this case, we'll show our point with a shaded circle. Here we don't have an equal sign in the inequality, so we'll show it with an unshaded circle. So let's show our table. So when x is, let's say, -2, 0, and 2, these are the points we want to use for x for the first graph for this one. So when I put in -2, I'll get -half times -2. 2 and 2 will cancel, negative and negative will give me a positive, so I'll get a 1. Then I put in a 0, anything multiplied by 0 is 0. Then I put in a 2, so what's -half times 2? This gives me a 1, -1 times 1 is -1. So let's plot these. So -2 and 1, which is right here, 0 and 0 is right here, and 2 and -1 is right here. So I'm going to shade these because they're included, but I won't shade the last one. Remember this rule over here, that because this doesn't have an equal sign, it's not included. So let's draw a line. And we don't need to extend the line beyond 2 because this graph is not applicable beyond 2. Not applicable, right? Now if this graph is applicable beyond 2, so let's make a new table. And we'll use values above 2. So x fx. So 2, 3, 4. Now if we plug in 2, we'll get 2. We'll get 3, we'll get 4. So let's plot this. At 2, we get a 2. Now this is included, so I'm going to shade. At 3, it's included. At 4, it's included. So let's draw this line. So your piecewise function will look like this. Okay, so we have this question. During physical ed class, Andrew recorded the exercise times in minutes and heart rates in beats per minute of 4 of his classmates. Which table represents a linear model of exercise time and rate? So we're looking for a straight line. Anything that increases consistently is what we are looking for. So let's look at choice 1. This goes up by 1 every time, right? This goes up by 5 every time. So this would be a linear model, right? We're looking for a linear model. So choice 1 could be possible. Let's look at the other one. So in all the cases, if you look at it, everything on the x-axis is increasing by 1, right? But let's look at what's happening with the y-axis. In student 3, this is going up by 7, then it's going up by 5, then it's going up by 5, then it's going up by 4. So it's inconsistent. Let's look at choice 4. Increase of 3, then of 1, then of 7, then of 2. Again, inconsistency. Let's look at 2. 8, 3, 5, and then 2. Again, inconsistent. So choice 1 is what we're looking for. That's a linear model. If you plotted it on a graph, you would get a graph like this. like this, where this is the BPM, the heart rate, and this is the time in minutes. This would start at 60. So we have this question over here. So they're asking you, they've shown you a graph, and they're asking you, so we are trying to find out the value when of f negative 3. All we've got to do in this question is mark these points and observe. Now when is x negative 3? Right here. What's the y value? That's what we are trying to find out. What's the y value when x is negative 3? So let's mark these 1, 2, 3, 4, 5, and 6. So our answer choice should be 6. Let's find that. Answer choice 1. So we have this question. When the graph, the piecewise graph, is drawn, how should the points be drawn on the graph for an x value of 3? So 3 is the point where the conditions are placed. Remember, in a piecewise function, whenever we have anything with the equal sign, either this way or this way, right? These mean inclusive points. So that means they are part of the graph, so we'll always shade them. Anything with the greater or less than sign, non-inclusive points. So unshaded circle or open circle as they are referring it to. Now let's read through the choices. Open circles at 315 and 313, not open for both of them because one should be closed, right? It should be closed for this one, closed here and open here. Let's evaluate. So when I put 3 in here and here, what do I get? What's 5 times 3? So that's 15. So this should be the closed circle over here. And when I put 3 in this part, I get 3 squared plus 4, which is 9 plus 4, and I get 13. This should be the open circle. So look for this. Open at 13, closed at 15. Okay, closed circle at both 3, and even that's wrong, so let's get rid of those choices. So they're saying open circle at 315 and closed at 313. That's the opposite of what we got. Let's look at the last choice. Closed circle at 315, open circle at 313. That's our answer. Answer 4. So we had this question. Which point is not a solution of the set of the equation? So the equation is given and we are looking for not a solution. That's the idea. Okay, that's the plan. So we know x and y in terms of coordinates. So we can plug them all in this equation right here. So our equation is 3y plus 2 is equal to x squared minus 5x plus 17, right? So let's test all of the conditions. So negative 2 and 10. So this is our x value, this is our y value. Let's plug it in. So if I plug in the y value, I'll get 3 times 10 plus 2, which is, sorry, like this, 3 times 10 plus 2. And equals negative 2 squared minus 5 times negative 2 plus 17. So 3 times 10 is 30 plus 2, 32. And here you get 4 plus 10 plus 17. So 4 plus 10 is 14. 14 plus 17 is 31. So this doesn't satisfy, right? This doesn't solve. So answer choice 1 is out. What about 2? -1 and 7. Let's plug these. So 3 times 7 plus 2. 3 times 7 is 21 plus 2 is 23. Okay, and let's do the other side. -1 squared minus 5 times -1 plus 17. So here when we squared 1 negative, we get +1. When we multiply -5 by -1, we get +5 and we get 17. Now if we add this, we get a 23. So this works, right? If we want, we can even test the other two and see which one is our answer. So 2 and 3. Just a choice 3, right? So we get 3 times 3 plus 2. 3 times 3 is 9 plus 2, which is 11. And then you have 2 squared minus 5 times 2 plus 17. So 2 squared is 4 minus 10 plus 17. 4 plus 17 is 21 if I do that. And minus 10 is 11. Oh, even that works, right? Oh, but we are looking for not a solution, remember that? So 3 works, 2 works, right? So let's erase this. This could be potentially our answer. This could be our answer. Okay. Alright, and then we have the last point, 5 and 5. So let's plug that in. 3 times 5 plus 2. 3 times 5 is 15 plus 2, which is 17. And then we have 5 squared minus 5 times 5 plus 17. So we get 25 minus 25 plus 17. These two cancel and you get 17. So 2, 3 and 4 work. Which one doesn't work? 1. So our answer is 1. Right, over here we've been given 2 graphs, right? The functions fx and gx are graphed below. Based on the graph, the solution to the equation fx is equal to gx, where they meet, right, which is this point right here, are the x-intercepts, the y-intercepts, the x values of the point of intercept. So we've got to find out what does the solutions of an equation mean. Solutions of an equation. Now remember, whenever they ask you for solutions of an equation, what does that translate as? We've already discussed this a couple of times. It's always the x values or the horizontal axis that they're looking for. Okay? Always x values. Whenever they ask for solutions, they're asking, hey, what are the x values? Or another way they'll ask you is like solve the equation. So all these keywords are referring to the same thing, right? Or they'll ask for what are the zeros of the equation. So let's find this answer choice. So all of these are referring to the same idea. Solutions, x values, solve the equation, zeros of the equation. Let's check for that. The x values of the point of intersection. Answer 3. Alright, calculate the average rate of change. So let's read our question first. The table below represents the height of a bird above the ground during flight, with PT representing height in feet, which is right here. That's the height in feet, and t is representing the time in seconds, right? Calculate the average rate of change from 3 to 9, which is right here to here, in feet per second. So what's the change in time? So let's look at these coordinates. 3, 6.26 and 9 3.41. So whenever they ask for the average rate of change, they're asking for the slope. And if you recall, the slope is defined as the change in y over the change in x. That's our formula. Okay, so let's work on this. So what is x changing from? From 3 to 9. Alright, so we have this. Paul plans to have a rectangular garden adjacent to his garage. He will use 36 feet of fence to enclose 3 sides of the garden. The area of the garden in square feet can be modeled by this function. So they didn't want you to find the area, they just gave you the function. Alright, where W is the width. On the set of axes below, sketch the graph of FW. So, what can we do with this expression? What all can we do? We can plug it into our graphing calculator or Desmos, or we can distribute. Both ways will give us a set of coordinates, right? So let's plug it in. What do we get? 36 minus 2. And in your calculator, you can use x instead of w. So you'll end up getting a curve, right? Okay, let's get a set of values from our table. So let's use, again, small values are better so they're using from 0 to 20. So let's use values of that nature. Maybe we can use the ones they've listed, like say they've already listed a graph. So let's use their set of values, right? We don't need any negative values because the width will never be in negative. So let's name it as W and FW. And let's put in these values 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. They've already marked everything for you. We just have to get the table and get our values for it. So at 0, we'll notice it's 0. At 2, it's 64. At 4, it's 112. At 6, it's 144. At 8, it's 160. At 10, it's 160 again. At 12, it's 144. At 14, it's 112 again. At 16, it's 64. 18, it's back to 0. Right? So let's plot these. Now we don't have anything in the negative axis, so we don't need this point. So let's get rid of this one, the 20. Because it's going to go to the negative. Now if you look at the pattern, it goes up to 160 and then it decreases, right? 160 is the maximum it's getting to. It's going to be a little more than 160 because when you draw the curve you'll notice. But 160 is our coordinate where we are reaching. And the x values are 8 and 10. So what's between 8 and 10? 9? So if you look at your calculator and check out the value for 9, you end up getting 162. That's our maximum value. Let's plot all of this. So at 0, it's 0. At 2, it's 64. So remember these values, how are they going up? So we've got a value here, 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 and then we have 40. So it's going up by tens. Right? This is our, and you can always add this you want to make things simple. So it's easy to put in the values, that way you'll get the exact point. At 2 we have 64, so a little above 60. At 4 it's 112, so a little above 110. At 6 it's 144. At 8 it's 160, exactly 160. At 10 it's back to 160. And at 9 we know it's 162, so a little above, right? Somewhere there. And 12, and they're generous. Remember the New York State Regents exam is already not asking you to do too many steps for graphs. It's just asking you to plug in the equation into the calculator and get responses. So use that as an advantage, get points, pass the exam. With the steps, you've got to show the steps. Alright, so let's plot this. So we get something like this. That's our curve. That's our curve. Right? So we've got this equation and we solved or drew the curve. Now there's another part to the question. It says explain the meaning of the vertex. Now remember the vertex is where the graph turns. Right? So this is our vertex, the maximum point. They're saying what does this mean? Now we know this is 162. Right? The maximum area, and this is our width in the context of the problem. So what's the meaning? So we'll say when the width is 9 feet, we get the maximum area of 162 feet squared or square feet, however you want to write it. Remember, math is a flexible language. It's like English where you can use different words to describe, so use that. But you need to know the terminology to express yourself. Alright? Alright, so we've got this question. The graph of y is equal to half x squared minus x minus 4 is shown below. The point A is negative 2, 0. So let's plot that. So if we put in the values, so A will be over here, negative 2, 0. B will be 0, negative 4. So let's plug that in, which is over here. This is B, right? This point is B. And this point will be 4, 0, which is C. Now they're saying which of these points can determine the zeros of the equation. Remember, the zeros of the equation are always on the x-axis. So which 2 points are on the x-axis? If you look at it, it's point A and C. So let's look at our answer choices which only have A and C. That's answer choice 3. Okay, so now Jan 2019 question 2. Which pair of equations would have negative 1, 2 as a solution? So we can plug all of these values for x and y into the equation and solve. So let's plug in negative 1 as x and 2 as y. Let's do that. So let's plug in x and y, right, in every part and see where all it solves. So if I take equation 1, there are 2 equations and let's just work with one of them. So y is 2, y is 2. So let's put that over here and we've got negative 1 plus 3. So this solves, right? So this equation is true. Let's check the second part of it. Y is equal to 2 to the power x. Now if I put negative 1 here, if you use your calculator, you'll get half. But y on this side is 2. Are these equal? Are these equal? They're not equal. So this doesn't work, right? Okay, let's try option 2. So you want both the answers to be the same. Y is equal to x minus 1. So you got a 2 for y. You got negative 1 minus 1. Now this is negative 2. These are not equal, so this doesn't work either. Let's check choice 3. Y is equal to x squared minus 3x minus 2. Right, let's plug in the values. Negative 1 squared is 1. Negative 3 times negative 1 is plus 3 and minus 2. 1 plus 3 is 4. 4 minus 2 is 2. Okay, that works. So this equation works. Let's test the second part of it. 4x plus 6. Okay, so we got 2. 4 times negative 1 plus 6. Negative 4 plus 6. What's negative 4 plus 6? It's 2. So this works. Let's just test answer choice 4. Probably we don't need to, but let's just test it just to make sure. So you got 2x plus 3y is equal to negative 4. Let's put in x as negative 1 and y as 2. So you get negative 2 plus 6 is equal to negative 4. Negative 2 plus 6 is positive 4. So this doesn't work. So answer 3. Alright, the graph of FT models the height in feet that a bee is flying above the ground with respect to time. The time traveled in t seconds. State all time intervals when the bee's rate of change is 0. Remember this word, rate of change is the slope. So wherever the slope is 0 is what they are asking you. A 0 slope is a horizontal line. Right? So where do you see horizontal lines? From here to here, right? So from 2 to 6, you can say from 2 seconds to 6 seconds. And then from 14 seconds to 15 seconds. And then what do you think, explain your reasoning? What do you think is happening? It's a bee. So it's probably flying, right? And sometimes it settles down. Maybe it sits to get some pollen and stuff like that, right? Maybe it's resting, I don't know. But what is it doing? At 1 feet, it's resting for 4 seconds. So it is probably at a standstill or at a pause or it's resting. Anything that you can convey your response as. So that's what our answer would be. Remember this part, explain your reasoning. They'll always ask for explain your reasoning. Don't just put 2 seconds, 2 to 6 seconds, and then 14 seconds and leave your answer over there. Please give your reasoning, something that is conveying what you're trying to do. Alright, so we've got this next question, Jan 2019, question 4. So it states that on a spring day, Elroy noted the time of day and the temperature in degrees Fahrenheit. His findings are stated below. So now they are showing different time periods. At 6 a.m., the temperature was 50. Now for the next 4 hours, the temperature is rising at 3 degrees per hour. So let's mark that at 6 a.m., it's at 50. So this is our temperature scale. This is our time, right? So at 6 a.m. it's 50. Now they're saying for the next 4 hours. So that means from 6 a.m. we're talking next 4 hours is 10 a.m. So the temperature is increasing at 3 per hour. So for 4 hours, if it's increasing 3 degrees per hour, for 4 hours it's going to increase by 12 degrees. Okay? 12 degrees. So from 50, if that's your starting, and it's increasing by 12, so what's your new temperature? 62. So at 10 a.m., the temperature is 62 Fahrenheit. Right? So let's mark that. So let's see what's happening here. So each line is representing a specific point. So is that 6 hours? That is 7 a.m., 8 a.m., 9 a.m., 10 a.m., 11 a.m., and 12 p.m. Right? Now at 10, we are at 62. So let's see what's happening on the y-axis. So we've got this line, this line, this line, this line, and then we reach 60. So each one's representing 2, because there are 5 lines within the space, like 1, 2, 3, 4, 5. So if you divide 10 by 5, you get 2. So each line is 2. Right, now we need 62. So this means this is 62 up here. So at 10, it's at 62. So let's mark that point right here. Right? And then for the next 6 hours, so we are at 10, the next 6 hours, how much is 6 hours after 10 a.m.? That will be 1, 2, 3, 4, 5, 6, which will be right here. Let's see what that is. After 12 comes 1 p.m., then 2 p.m., then 3 p.m., and then 4 p.m. So at 4 p.m. is the next stop. And they're saying that it's increasing at 2 degrees per hour for the next 6 hours. So again, it's increasing by 12 degrees Fahrenheit, right? Or increase is 12. So from 62, it will go up. It will go up to 72, 74, 76, 78, right? At 4 p.m., we are going from 62, we are adding another 12. So we go to 74, which is up here, right? And then the temperature then stayed steady until 6 p.m. So 6 p.m. is right here. So it's still at that temperature. So it's a horizontal line, right? Here, what do we get? We get a horizontal, a sloped line for the first part. Right, so let's draw that. So we got that part, right? Then we have this. So that's our first expression, or our first part of the graph. Then for the next 2 hours, so now we were at 6 p.m., right? Next 2 hours will be 8 p.m. So let's mark that, 7 and 8. For the next 2 hours, it's dropping by 1 degree every hour. So it's going down by 2 degrees. So at 8, it's coming at 72, right? So let's join these two. Sorry. Not the best line, but there we go. So that's our graph right there, right? The temperature then suddenly dropped steadily until the temperature was 56 degrees at midnight. So at midnight it's at 56. So let's go to 56, which would be over here. So let's join the last 2 points. So that's what our graph looks like. Then they've got a few questions after that. So the first one is state the entire time interval for which the temperature was increasing. So where all is it increasing? From 6 a.m. through till 4 p.m. So 6 a.m. to 4 p.m. Right? It's increasing. The rest, then it's constant or decreasing. Then they say average rate of change. Now, if you read this word constantly, remember it's the slope. This is referring to the slope. And that's always change in y divided by change in x. Now, let's check our readings. At 6 p.m., we are at 74. And at midnight, we are at 12 and 56. So what's our change in the temperature? You can always make your right angle triangle. So from 6 p.m. to 12, it's 6 hours, right? And from 74 to 56, it's 18 degrees. A drop of 18 degrees, but it's a drop. That means it's cooling down, right? So let's do this math. Negative 18 divided by 6, which is negative 3 degrees Fahrenheit per hour. So how would we describe this? We can either say that, hey, it's negative 3 degrees Fahrenheit per hour, which will be a correct answer. Or you can say that the temperature decreased by 3 degrees Fahrenheit every hour. So it's cooling down. What happens, like for example, where we live, the nights are much cooler than the day. So just giving you a question regarding something that you might be experiencing every day. Alright, so we've got 4 graphs here. I plotted the graphs on Desmos, and this is option 1, this is option 2, option 3, option 4, right? And I think I covered some of the things, so let's just move them around. Okay, so we need to get rid of a few things, fix a few errors. So let's fix this again, since I transposed the graph of my pastings. So let's mark the axes, right? So we've got 0, we've got 1, we've got 2, we've got 3. Here we have 1, 2, 3, 4, 5, 6, right? Here we have negative 1, negative 2. Now look for a graph that shows you this shape. So it's either, we know that 1 and 2 do not fit. Look at, 1 and 4 do not fit. Look at the shape of the graph. This one's like this, number 4, and even 1 is like this, right? So let's look for choice number 2 and 3. Where does this cut? This cuts at 2. This cuts at 4, right? And then this cuts over here at 2 and 1. And then this cuts at negative 2. So are those the same points we are getting over here? 1, 2, 4. So it's answer choice 3 is our answer. Answer 3. Alright, so I drew the graphs for this again. There are 3 graphs, A, B, and C. And we've got to compare what is happening with them, right? Or figure out what's happening. So we have these 3 graphs, right? So I drew the graphs on Desmos. You can obviously use your graphing calculator to plug in these equations and then compare them. So which statement is true? Let's look at the graphs. Now A is cutting over here. Which is right in the middle, 1, 2, 3, 4. So this is 2.5, right? And it's cutting up here, which is 1, 2, 3, 4, right? And similarly, we've got this value over here, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. And let's check this one. This is 0, -1, -2, -3, -4, right? B and C have the same zeros. So what's the zeros on B? It's -2 and -6. So this has a zero of, zeros are at -2 and -6, right? And similarly for C, the zeros are up here. Zeros are at -2 and -4 and -4. Okay, so those are where our zeros are. And zeros is also spelled with an E. So let's check where the y-intercept is. -1, -2, -3, -4, -5, -6, -7, -8. That's where our y-intercept is here. Over here, the y-intercept is up here, which is 11, 12, at 12. Okay, A and B have the same y-intercept. So A has a y-intercept at 4, right here where it cuts the y-axis. B has a y-intercept of 12, so even that doesn't work. B has a minimum value, which is right here, minimum, and C has a maximum value. Oh, that looks like true, right? Okay. And C has a maximum value, which is true. A has a minimum value. A is not minimum or maximum. So A does not work, right? So choice 4 is wrong. So the answer is 3. Okay, next question. Which ordered pair does not represent a point on the graph? So we can either plug these in or use our calculator and see what's happening with our set of values. So I drew the graph for this, and I also got a table. So this is what I get. So I got this, right? Now we'll just look at our answer choices. So let's look at answer choice 1. We see 1 over here, -1.5 and 15.25. Then we see 2 over here, 0.5 and 7.25. Then we see 3, but we see 1.25 and 10.25. This one's showing 10.4375. And let's look at our fourth response. So 2.5 and 23.25. So even that's correct. This is correct. The only one which is incorrect is 3. Alright, so we got this graph. We've done piecewise questions. Remember, anything without the equal sign will be an unshaded circle. Anything with an equal sign will be a shaded circle. Right? So let's make our table for fx is equal to x. I'll use yellow, it's easier, it's brighter, shows you more info. So -5, -4, -3, -2, -1, 0, 1 and 2. So I like plotting the point that we don't need so that we can show the unshaded point over there. So 5, 4, 3, 2, 1, 0, 1, 2. So absolute value just makes everything positive, right? And then we've got fx is equal to -2x plus 10. So let's plug in those values. 2, 3, 4, 5, 6. So -4 plus 10 is 6. -6 plus 10. I'm plugging in 2, 3, 4, 5, 6 in there. So -6 plus 10 is 4, -8 plus 10 is 2, -10 plus 10 is 0, and then -12 plus 10 is -2. So let's plot these. We've got 0, 1, 2, 3, 4, 5, 6, and we need till 6 on this axis. -1, -2, and please mark these points. These are what will get you points, okay? -4, -5. So at -5, we've got 5, which is here. At -4, it's 4. At -3, it's 3. -2, it's 2. At -1, it's 1. At 0, it's 0. At 1, it's 1. And at 2, we leave this shaded. So let's draw a line and then I'll shade the points. So let's shade these. So these means the graph wants these points, right? These are included. That's why I'm shading them. The one which is not included is the last point. Now let's plot the other few points. At 2, it's 6, which is up here. This we need. So, sorry about that. So at 2, it's 6. At 3, it's 4. Right? At 4, it's 2. At 5, it's 0. At 6, it's -2. So now we got this line to draw. And we'll shade these points because these are the ones that are needed. Remember this equal sign. So this is what we get. Alright, now we've got these two graphs. 2x squared minus 8x plus 3, and gx is equal to -2x plus 3. So let's name this as y and x, and let's mark 1, 2, 3, 4, 5, 6. And then let's plot these and get a table for it. So I put in all these values, right? For the table, you can obviously use your calculator or Desmos, right? Use the calculator. I would urge to use the calculator. Reason being, because that's what you're going to use in your exam. So do as much on the calculator to practice, right? Okay, negative 113. Let's plot these. Negative 113. 0 is 3. 1 is negative 3, so we need some negative values. 2 is negative 5. Just down here. At 3, it's back to negative 3. 4 is 3. And 5 is 13. Okay, so let's draw this. So this is y is equal to fx. Let's draw gx, negative 2x plus 3, this graph down here. So at negative 2, we've got 7, which is up here. I'll use a different color. Negative 1 is 5, which is here. 0 is 3. 1 is 1. And 2 is negative 1. And then let's draw the line through these points. So now we got this. This is y is equal to gx. They're asking you in the question, there's even this part, where are they equal? Right here, right? So what's our x value at this point? 0. What's our y value? 3. So our solution set is 0, 3. Where the two graphs are equal. Okay, next question. The functions fx and gx are graphed on the set. So this is fx, this is gx. For which values of x is fx not equal to, remember this sign, not equal to gx. So where all is it not equal? So they are equal over here. We have to specify a point where they are not equal. So let's mark these 0, 1, 2, 3, negative 1, negative 2, negative 3. So it's equal at negative 2. It's equal at negative 1 for x, and it's equal at 2. So these are our x values where fx is equal to gx. So when x is negative 2, negative 1, or 2. Let's look at our answer choices. We want anything other than this. Any value other than these. Because the question is saying where is it not equal to, right? So let's see. Negative 2 is here. Negative 1 is here. 2 is here. Which one's the odd one out? Answer 3. Okay, a child is playing outside. The graph below shows the child's distance dt in yards from home over a period of time t in seconds. So this is your distance, this is your time in seconds. Which interval represents the child constantly moving closer to home? So dt is the child's distance from home. So the further away he is away from home. The closer he is to 0, this is where home is at level 0. So when is he moving closer to home? So here, from here to here, he's coming closer to home, right? Closer. Here he's moving away, then he comes closer to home from here. This is again closer to home. Then he's moving away, and then don't know what he's doing here, maybe at a park or something, or visiting someone. So where all is he closer? From 0 to 2, right? And then from 2.5 to 3, but that's not mentioned, so it's 0 to 2 is the answer. Answer choice is 1. So we have this question on this set of axes graph. The line of this equation is 2y is equal to negative 3x minus 2. Once again, plug it into the calculator or Desmos. And let's solve this, right? Now with the calculator, the restriction is that it needs to have y is equal to, right? Now you see this extra 2 with the y. We need to get rid of that. Use SADMAT. Get rid of this 2. It's multiplying. So what's the opposite? Division. So divide every part by 2. I get negative 3 over 2x minus 1. Now let's plug in values for x to create a table. So let's put in 0, which is one of the simplest values for x, and let's put in 2. For any straight line, you need a minimum of 2 points. But for a curved graph, I'll put that on this end, curved graph, show at least 5 points, right? So let's put in 0. If I put in 0 for x, what do I get? Anything multiplied by 0 is 0, so I get a negative 1. And then let's plug in 2. Negative 3 times, or negative 3 times 2 is negative 6, divided by 2 is negative 3, and minus 1, so I get negative 4. Let's plot these. At 0 we've got negative 1, which is down here. At 2 we've got negative 4, which is over here. And we can draw a straight line through it. So that's our straight line, which you can obtain from the calculator. Now, there's another part to this question. It says this linear equation contains the point 2, k. Now, this is our x value, this is our y value. We've already solved for 2, k. Look at this. X is 2, x is 2, y is negative 4. So, what's our value of k? Negative 4. That's our answer. Okay, so we've got another piecewise function. So we've got 2 equations over here, which we'll plot. Alright, so let's work with both of them separately. So let's do hx is equal to 2x minus 3. And we need values less than 0. So anything below 0, which are all negative values. Right? So take 2 values of x. Again, remember this is a linear equation. How can we say that? Because the exponent of x is 1. Right? So if it's anything higher, like x squared in the second part, that would be a quadratic equation. So you can figure out if it's linear or non-linear just by the equation. So let's put in values. Let's put anything negative. So -1, -2. Plug that in. What's 2 times -1? -2 minus 3, -5. 2 times -2 is -4 minus 3, -7. And then let's plot the second part. Let's define a table for that. And our range is 0 to 5. So let's put in 0, 1, 2, 3, 4, 5. We've got hx. Now when we put in 0, we get -5. When we put in 1, we get 1 minus 4 minus 5. Let me solve that. So we get -8, and then we get 4 minus 8 minus 5, which is -9. And then we get 9 minus 12 minus 5, -8. Then we get 16 minus 16 minus 5, which is -5. And then we get 25 minus 20 minus 5, which gives us 0, right? So let's plot all these points. So both graphs. Let me put the markings first. Alright, so at -1 it's -5, so that's here, and at -2 it's -7, which is right here. And if I use 0, I'll get -3, which will be over here. And I won't shade this, okay? The reason is because it's not needed on the graph. So let's plot this part. So what I get. And I'll shade these. Sorry. And leave the 1 at 0 because of this thing. Remember this, it doesn't have an equal sign, so this is not included. So this is not included. Okay, and then let's plot the second part of the graph. Right? So at 0 they say it's -5, and 1 is -8. I need a few more values. And then 2 is -9. 3 is -8. And then 4 is -5. And then 5 is 0. So let's plot this. So I'll get something of this nature. This is hx is equal to x squared minus 4x minus 5. This is hx is equal to 2x minus 3. And all of these are included. So okay, a very apt day to do this question. A snowstorm started at midnight. For the first 4 hours, it snowed at an average rate of 1/2 inch per hour. So for 4 hours, if we multiply 1/2 by 4, we get 2 inches. Okay, the snow then started to fall at an average rate of 1 inch per hour for the next 6 hours. For the next 6 hours, 1 times 6 is 6 inches. And it started at midnight. Then it stopped snowing for 3 hours. So no more accumulation, no more snow accumulation. Then it started snowing again at an average rate of 1/2 inch per hour for the next 4 hours. So it's back to a 2 inches of snow accumulation. On the setup axis below, graph the amount of snow accumulated over the time interval of the storm. So let's plug this in. It starts at midnight, and then it goes for the hours it accumulates, and then for the next it's accumulating another, stopped snowing for 3 hours, and then it started snowing again for the next 4 hours. So midnight is right here. And these are 1, 2, 3, 4, 5. So for the first 2 inches, so that would be up here, right? Hours, which would be at 10. It's accumulating another 6 inches, so that would be up here. And then 4 hours 2 inches, so that would be at 14 and 2 inches. Okay, so this is the graph, or these are the points. So for the first 4 hours, 2 inches are accumulating, which we'll put here. And then for the next 6 hours, there's an accumulation of 6 inches. And then it doesn't snow for 3 hours. And then it snows again for the next 4 hours. So that's our graph right here. Okay, 17-hour time period, and you've gotten 10 inches of snow. Something you'll experience in the north, especially. Alright, have a nice one.